Good morning, students. Chapter 3, Current and Electricity. Now, next topic is connections of resistors. Okay, a series and parallel connection of resistors. First of all, we will see series connection of resistors. See, we know that if we have one resistor, it is symbol of resistor, having resistance R, current is flowing from A to B in this direction, I. Okay, if we have one resistor having resistance R, current flowing from it is I. So what is potential difference? Potential difference between two ends or between two points A and B. Potential difference between two ends. V is equal to, according to Ohm's law, we can write it is IR. According to Ohm's law, we can write it is V is equal to IR. Okay. Now, here we have to identify series connection of resistors. See, for example, we have two resistors R1 and R2 connected in series between A and B. Let two resistors R1 and R2 are connected in series between A and B, like this. See, first resistor, second resistor. Let it is point A, it is point B, and let this intermediate point is N. Okay, let it is resistor R1, it is resistor R. Clear about this? Okay. Now, how we can identify it is series connection? In series connection, see, two ends of this resistor R1 are A and N. Two ends of this resistor R2 are N and B. Means they have one component only. Okay. Or how to identify? If I say current flowing from A is I, then yes, I current is flowing from this resistor R1. Okay. Now there are no other way. There are no other ways. Okay. Means charge or current entering this resistor is equal to current leaving this resistor, because current means flow of charge. Current means flow of charge, and according to law of conservation of charge, charge is never created or never destroyed. Okay, charge entering at some point is equal to charge leaving at that point. So here, if current I enters this resistance, yes, current I leaves this resistance, and also current flowing from this second resistance is same, according to law of conservation of charge. According to law of conservation of charge. Okay, then yes, first point in series connection, you have to remember that according to law of conservation of charge, law of conservation of charge. Okay, as there is one path only, charge entering R1, charge entering R1 is equal to charge entering in R2, and yes, rate of flow of charge is called current. So therefore, current I from resistor R1 and R2 is the same. Current flowing from them is same. According to law of conservation of charge, charge is flowing as there is one path. Charge flowing from this resistor from this path, and as current flowing from this resistor and this resistor will be same. So first thing you have to remember, current I is same. Current I is same in series connection. Now what about potential difference? See, current flowing from first resistor is I. Current flowing from second resistor is also I, but their resistances are R1 and R2. What is potential difference across What is potential difference across R1? I can write V1 is equal to it is I R1. Similarly, potential difference across R2. Potential difference across R2. V2 is equal to it is IR. V2 is equal to it is IR. Clear about this? Potential difference across R1 is V1. Potential difference across R2 is V2. Okay, this between point A and N, potential difference is V1. Between point N and B, potential difference is V2. Then what is potential difference between A and B? Okay, then potential difference between A and B, V is equal to, it is V1 plus V2. So you can write V is equal to, it is IR1 plus IR2. Clear about this? Okay, now what we have to do? Here we have to replace these two resistors. Here we have to replace these two resistors by an equivalent resistance like this. Suppose I want the equivalent resistance between A and B. Between A and B. Let equivalent resistance is RS. RS means series connection. What is current flowing from A? It is I. What is current coming to point B? Yes, it is also I. It is I. Clear about this? Clear about this? Then see what we want to do. We want to find equivalent resistance between A and B. It is its equivalent circuit. See, this resistor R1 and R2, they are replaced by RS. What is potential difference between A and B? Yes, it is V. Yes, it is V. Then according to Ohm's law, what is relation between RS, I and V? What is relation between RS, I and V? Yes, between them relation is let equivalent resistance. Let equivalent resistance between A and B. Between A and B is RS. Is RS. Then RS, I and V. What is relation between them? We can write yes. V is equal to I RS. Okay. So yes, it is equation number 1. It is equation number 2. Compare these two equations. What we will get? I RS is equal to IR1 plus I top that. Then it is RS is equal to R1 plus R2. RS is equal to it is R1 plus R2. Clear about this? So yes, when two resistors R1 and R2 they are connected in series, what is their equivalent resistance? Equivalent resistance RS is equal to R1 plus R2. What is relation of current? Current flowing from each and every resistance is same. What is relation of potential difference? V is equal to V1 plus V2. Remember chapter 2. Series and parallel connection of capacitors. You have to remember three relations. First, again, for current, in series connection, current flowing from resistor is same. What about voltage? Potential difference? V is equal to V1 plus V2. What about resistance? RS is equal to R1 plus R2. Clear about this? Now, if you have n resistors, if n resistors are connected in series, then what is equivalent resistance RS? Equivalent resistance RS is equal to R1 plus R2 plus R3 plus S2 plus so on R. Clear? If n identical capacitors are connected, if n identical resistors are connected in series, then what is equivalent resistance? RS is equal to yes, R plus R plus R plus this 2 plus R means it will be NR. Means it will be NR. Clear about this? So yes, for series connection you have to remember such points. If I am taking one example, if R1 is equal to 6 ohm, R2 is equal to 4 ohm, clear? R1 is equal to 6 ohm, R2 is equal to 4 ohm. Then what is equivalent resistance for series connection? Then yes, Rs is equal to, it is R1 plus R2 is equal to, it is 6 plus 4 is equal to, it is 10. Then see how to write result. In series connection, equivalent resistance is greater than greatest among combination. Greatest among combination. Clear about this? Okay, R1 is 6, R2 is 4. What is that series connection? It is 10. It is greater than greatest among combination. So, when you want more resistance, maximum resistance, connect resistors in series connection. Connect resistors in series connection. Clear about this? So yes, it is series connection of resistors. Now we will see parallel connection of resistors. Now parallel connection of resistors. See, parallel connection of resistors. If again I have 2 points A and B. Okay. If resistors are connected between A and B like this. If resistors are connected between A and B like this. Okay, it is resistor R1 and it is resistor R. Clear about this? Okay. Between A and B, two resistors R1 and R2 are connected. So let R1 and R2 are resistors connected between A and B. Between A and B. Okay, now see, I am assuming here, okay, let current flowing from this point A is I. Current flowing from this point A is I, means charge is flowing. From this point, this charge gets distributed, divided into branches. Now as their resistances are different, yes, charge flowing from each resistor is also different. Okay, so yes, from point A, charge is flowing. From this point, charge is divided into branches. Okay, yes, charge flowing per unit time is called current. So I am assuming, let here from this resistor, current flowing is I1, and from this resistor, current flowing is I2. Clear about this? So I have how to write? See, let current flowing from point A is I. Okay, current flowing from point A is I. This current I is then distributed in two resistors. Okay, that is I1 and I2. So according to law of conservation of charge, again charge entering this point is equal to charge in these two branches. For example, if I say charge flowing from this point A is 100, if charge flowing from this first resistor is 60, then what is charge flowing from this resistor second? 40. 100 total charge from this 60. So from this 40. So yes, charge flowing per unit time, it is called current. So according to law of conservation of charge, if current flowing from A is I, and in these two branches, if it is distributed, if it is divided, then according to law of conservation of charges, I can write I is equal to I1 plus I2, equation number 1, and it is equation for current in parallel connection. Okay, yes, current I is equal to, it is I1 plus I2. Clear about this? In series connection, current remains same. Yes or no? Yes. Now what about potential difference? See, two ends of these resistors, AB. Two ends of this resistor, AB. Yes, means this A and this resistor R1 and R2, they are connected between two common points A and B. They are connected between two common points A and B. Clear about this? So whenever two resistors are connected between two common points, potential difference between them. See, potential difference between two ends of resistor R1. Which two points? A and B. Which 2 points? A and B. V is equal to I R1. V is equal to I R1. Sorry, it is I1 R1. Okay. Similarly, potential difference between two ends of resistor R2. Hello, resistor R2 is again connected between points A and B. So I will write V is equal to it is I2R. V is equal to it is I2R. Clear? So yes, as these two resistors are connected, between two common points, potential difference across them is the same. So here I can write, yes, potential difference V is same for parallel connection. Clear about this? Now from this make I1 as subject, then I1 is equal to it is V upon R1. From this make I2 as subject, then I2 is equal to it is V upon R2. Yes it is. Yes it is. Clear about this? Okay. Now put value in equation number 1. So I can write I is equal to, what is value of I1? It is V upon R1. What is value of I2? It is V upon R2. Clear about this? Now again, these two resistors are connected between A and B in parallel connection, and we want to find its equivalent resistance. Means it is A, it is B. Equivalent resistance is let RP. Okay, clear? Current flowing from A is I. Now see, here it is. Current flowing from this I. It is divided in these two branches. I1, I2, I1, I2, I1, I2, I1, I2. At this point, they again recombines. And yes, current entering in point B is again I. Yes, it is law of conservation of charge. Clear about this? From point A, I, divided into branches. I1 and I2, I1 and I2, I1 and I2. At this point, they again recombine and forms current I. Clear about this? So yes, between 2 points A and B, equivalent resistance is like RP. Current flowing from them is I. Yes, it is I. And what is potential difference between two ends? It is V. Between A and B. See, here it is between A and B. It is V. So now how to write relation between them? Again, yes, we can write here. If equivalent resistance is RP, if equivalent resistance is RP, then I can write V is equal to IRP. V is equal to IRP. Clear about this? Okay. Then what is value of I? I is equal to, it is V upon RP. Put this equation of I here. So you will get V upon RP is equal to V upon R1 plus V upon R2. V cut. So it is 1 upon RP is equal to 1 upon R1 plus 1 upon R2. Okay. So it is equation of resistance in parallel connection. Again, 3 things you have to remember. For parallel connection, 1 upon RP is equal to 1 upon R1 plus 1 upon R2. Potential difference for each and every resistance is same. Current is divided, means I is equal to I1 plus I2. How to identify series and parallel connection? resistors on same path, they are considered in series connection. But when this current divides in branches, then yes, such two branches, such two resistors, they are in parallel connection. Clear about this? Okay, so yes, it is equations for parallel connection of resistors. Now if you are given n resistors, if n resistors are connected, in parallel, okay, then what is equivalent resistance? 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus this 2 plus 1 upon R2. Okay, for an identical resistors, 1 upon Rp is equal to, yes, it is 1 upon R plus 1 upon R plus 1 upon R plus this 2 plus 1 upon R, means it is n upon R. So what is Rp? Rp is equal to R upon it. Rp is equal to, it is R upon it. Clear about this? Okay, so yes, in series and parallel connections, you have to remember each and every relation. Now for example, if I have R1 is equal to 6 ohm, R2 is equal to 4 ohm, okay, then yes, we know equation 1 upon Rp is equal to 1 upon R1 plus 1 upon R2, okay, then Rp is equal to, it is R1 R2 upon R1 plus R2. Yes, if you simplify this equation, you will get this answer. R1 R2 upon R1 plus R2. R1 R2 upon R1 plus R2. Okay. R1, what is value of R1? 6. R2, 4 divided by 6 plus 4. 6 into 4, 24 divided by 10 is equal to, it is 2.4 ohm. Then again, yes, we have to make one statement. R1 6, R2 4, but what is the equivalent resistance? 2.4, which is less than 4 ohm. So yes, in parallel connection, equivalent resistance is smaller than smallest among combination. Clear about this? Yes, we have discussed the same types of statement for capacitors. Yes or no? Yes. So it is parallel connection of resistors. Clear about this? Series and parallel connections of resistors. Okay? Okay, now we will see some questions based on series and parallel connection. See, exercise 3.3. 1 ohm, 2 ohm and 3 ohm resistors are connected in series. First question is, what is total resistance of combination? Yes, for series connection it is easy. If total resistance of combination is Rs, then Rs is equal to, it is R1 plus R2 plus R3 is equal to 1 plus 2 plus 3. 1 plus 2, 3 plus 3, it is 6 ohm. Simple. First answer is simple, 6 ohm. Total resistance is 6 ohm. Clear about this? Okay. Now, second question. If combination is connected to a battery of EMF 12 volt and negligible internal resistance, obtain potential difference across each resistor. See, if I draw its figure, it is like this. 3 resistors connected across the battery of 12 volt. So I can write V is equal to 12 volt. Actually, EMF is indicated by E. But as here internal resistance is 0. Internal voltage is equal to voltage. Yeah, EMF is equal to voltage. So here V is equal to 12. It is R1, R2 and R3. Clear about this? Now, if you have to find potential difference across each end, across this R1, R2 and R3, then what is equation? Yes, to find potential difference V. If you make V as subject, then what is the equation of V? V is equal to IR. V is equal to IR. Yes, you know what is value of R1, R2 and R3, but you don't know what is value of I, current. Then first of all, we have to find current. We have to find current. What is total resistance of connection? Total resistance of combination R1 plus R2 plus R3 is equal to 6 ohm. Yes or no? Total resistor of circuit is 6 ohm. Then what is total current flowing from battery? I am assuming it is I. And how to find this current? See, the total current, okay, total current from cell I is equal to, it is V upon Rs. Total connection, total resistor. What is value of V? Yes, V is equal to, it is 12. What is value of Rs? Rs means total resistance, it is 6. Then it is 2 ampere. Clear about this? Then yes, current flowing from battery is 2 ampere. And yes, in series connection, current is same. Current is same from each resistor. Current is same for each resistance. So potential difference across R1, V1 is equal to IR1. What is value of I? It is 2. What is value of R1? Where is R1? Where is R1? Here it is this one. So it is 2 into, it is 2. Clear about this? Similarly, potential difference across R2, V2 is equal to IR2. I2, what is value of R2? Yes, it is 2. 2 into 2, it is 4 volt. Clear about this? Now, potential difference across R3, that is V3 is equal to, it is IR3 is equal to 2. What is value of R3? Yes, it is 3. So it is 3 into 2, it is 6 volt. Clear? So yes, it is your answer. Potential difference across R, 2 volt. Across R2, 4 volt. Across R3, it is 6 volt. How to verify your answer? See, V1 plus V2 plus V3. 2 plus 4 plus 6, it will be 12. It will be 12, yes. In series connection, we have proved V is equal to V1 plus V2. V is equal to V1 plus V2. So yes, it is your answer. Clear? See, you have three variables, V, I and R. If you want to find V, you must have value of I and R. Clear about this? Now see next question. See what is next question. Here it is. You are given again three resistors. R1 is equal to 2 ohm, R2 is equal to 4 ohm and R3 is equal to 5 ohm in parallel connection. In parallel connection. Your first question is find total resistance. How to find total resistance? Total resistance 1 upon RT is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 is equal to 1 upon 2 plus 1 upon 4 plus 1 upon 5 is equal to, take LCM 20. Take LCM 20. Here it is 2. Then 2 multiply 10. Yes or no? As here it is 4. You have to multiply with 5. As here it is 5. You have to multiply with 4. So it is 10 plus 5 plus 4 is 19 by 20. Yes or no? But if you want to find RP, don't forget to take its inverse. Okay. RP is equal to, it is 20 by 19 ohm. Clear about this? So yes, it is resistance Rp is equal to 20 upon 19 ohm. Okay. Now, question B. Again, if these three capacitors which are connected in parallel connection is connected to a battery having EMF V is equal to 12 volt and internal resistance 0, then find current through each resistor and total current. See, three resistors in parallel connection. In parallel connection. Okay, R1, R2 and R3 with a battery of voltage V is equal to 20 volt. Yes, in parallel connection we know that potential difference between each and every resistors is same and is equal to potential difference or voltage of battery. So here potential difference across each resistor is V is equal to 20 volt. V is equal to 20 volt. Clear about this? So now, how to find current flowing from first resistor? Current from first resistor current from first resistor I1 is equal to V upon R. I1 is equal to V upon R1. What is value of V here is 20. What is value of R1? What is value of R1? Where is R1? Yes, here it is 2. So here it is 2. Okay, 20 by 2 it is only 2 ampere. Clear about this? Clear about this? Okay, now similarly, current flowing from second resistance I2, it is V upon R2. What is value of V? 20. What is value of R2? It is 4. So yes, it is 5 ampere. Clear? Okay, what is value of I3? Current flowing from the resistor, V upon R3, it is 20 divided by 4 divided by 5, then it will be, it is 4 ampere. Clear about this? Clear about this? Any doubt? Okay. Okay, 5 plus 4 it will be 9. 9 and plus 2 it will be. Okay, so yes, how to find this total? How to find this total? Okay, clear about this? Now, your second question is, what is the total current? What is the total current? How to find total current? How to find total current? Total current I is equal to, it is I1 plus I2 plus I3 is equal to, what is value of I1? See, it is 20 by 2 means it is 10. 20 by 2 means it is 10. Okay, so I1 is equal to, it is 10. What is value of I2? It is 5. What is value of I3? It is 4. So 10 plus 5 plus 4, it will be 19 ampere. It will be 19 ampere. Clear about this? So current from first resistor I1 V upon R1, 20 by 2 it is 10. I2 V upon R2, 20 by 4 it is 4. I3 V upon R3, 20 by 5 it is. Clear? Total current is equal to 19 ampere. Now how to verify your answer? See, what is total resistance RP? 20 upon 19. What is voltage? V. Okay, so yes, how to find total current from this equivalent resistance? You can use this equation. I is equal to V upon RP. What is value of V? It is 20. What is value of RP? It is 20 upon 19. 20 upon 19. To see this 20 cut, then what is total current? It is 19 ampere. So yes, it is how you can verify your answer. It is how you can verify your answer. Clear about this? Okay. So yes, these are some questions based on series and parallel connections of resistors. See, exercise question number 3.20, n resistors. Question A, n resistors, each of resistance R is given. You have to find ratio of maximum resistance to minimum resistance. See students, in series and parallel connection, we have discussed about one example, 6 ohm, 4 ohm. Okay, in series connection we got answer 10 and in parallel connection we got 2.4. So from this it is clear. If you want maximum resistance, connect resistors in series connection. If you want minimum resistance, connect resistors in parallel connection. Okay, so here for maximum resistance, connect them in series. Connect them in series. And yes, you have n resistors, each of resistors are. Then yes, you know that R maximum is equal to, it is R series, that is equal to, it is NR. Clear about this? Similarly, for minimum resistance, connect resistance in parallel. And you know its equation, R minimum is equal to RP is equal to, it is R upon N. It is R upon N. Now you have to find ratio of R maximum to R minimum. Then R maximum upon R minimum is equal to, R maximum upon R minimum is equal to, it is NR upon R divided by N. R cut. This sign will be remainder. So your answer will be this. Yes. So remember, maximum resistance to minimum resistance is equal to N square. If you are asked R minimum upon R maximum, then your answer is 1 upon N square. Okay. Now question B. you are given three resistors, 1 ohm, 2 ohm and 3 ohm. How will we combine them to get an equivalent resistance of? You have to solve 4 questions. Okay, what is question? Understand? You are given 3 resistors. If I want equivalent resistance 6 ohm, then how to combine these 3 resistors? How to combine these 3 resistors? Yes, whenever there is connection of resistors, first of all we will think series and parallel. First of all we think series and parallel. Then assume, assume. First of all we have to take probability, yes it is right or wrong. Then if I am taking 3 resistors in series connection, 3 resistors in series connection. If it is R1, it is R2 and it is R3. Okay, then what is its equivalent resistance? Rs is equal to R1 plus R2 plus R3 is equal to 1 plus 2 plus 3 is equal to 6 ohm. So yes, I get my answer. Yes or no? It means to get an equivalent resistance of 6 ohm, R1, R2 and R3, they are connected in series connection. They are connected in series connection. Clear about this? So it is your question. How will we combine them to get this? Now second question. How will you combine them to get an equivalent of 6 upon 11? Again, first of all, if you have connection of resistors, first of all we will think the easiest thing, that is series. Then we can assume parallel. Here I am assuming, suppose these 3 vectors are in parallel connection. Okay, suppose these 3 vectors, these 3 resistors, they are connected in parallel connection. It is R1, R2 and R3. Okay, let's see for parallel connection what is the equation? 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So here it is 1 upon Rp is equal to 1 upon it is 1 plus 1 upon it is 2 plus 1 upon it is, yes it is 3. Yes, it is 3. Clear about this? Clear about this? Now take LCM 6, that is equal to 6 LCM. Here it is 1, so here you have multiply 6, 2, multiply 3, 3 multiply 2. So 6 plus 3, 9, 9 plus 2 it is 11. So it is 11 by 6. It is 11 by 6. And if you take Rp, then Rp is equal to it is 6 by 11 ohm. Then in this case, to get an equivalent resistance of 6 upon 11 ohm, to get an equivalent resistance of 6 upon 11 ohm, you have to connect R1, R2 and R3 in parallel connection. In parallel connection. Clear about this? Now third one. To get an equivalent resistance of 11 upon 5 ohm. 11 upon 5. See, 3 resistor series over 3 resistor parallel over now their combination. Yes. There are numbers of cases. Okay, if R1 and R2 are in series in parallel with R3, okay, R1 and R2 in parallel in series with R3, yes, you can assume. So first of all, you have to take probability. Okay, suppose I assume, okay, yes, your answer is it is 11.5. So if I assume R2 and R3, they are in series connection in parallel with R1. Okay, suppose like this. It is R1, it is R2, and here it is R3, and here it is R3. I am assuming, I don't know it is right or wrong, okay, I am assuming if R1 and R2 they are in series connection, in parallel with R3. Then first of all find series connection of R1 and R3. That is R1 is equal to R1 plus R2. What is value of R1? R1 is equal to 1. What is value of R2? It is 2. Then yes, your answer is it is 3 ohm. Clear about this? Now I can draw its figure like this, like 2 resistors. It is R12 and here it is R3. So from this I can say R12 and R3 they are in parallel connection. Okay, R12 and R3 they are in parallel connection. Then how to find its equivalent? Okay, 1 upon R is equal to 1 upon R12 plus 1 upon R3. What is value of 1 upon R12? It is 3. What is value of R3? What is value of it is 3. Okay, so yes, it is 1 upon 3 plus 1 upon 3. Means you will get it is 2 upon 3. Then 1 upon R, it is 2 upon 3. So what is value of R? It is 3 by 2. Do we have any answer? No. Means this assumption is wrong. This assumption is wrong. So now take another probability. Take another probability. Okay, if R2 and R3, they are in series connection in parallel with R1. In parallel with R1. Then first of all you have to find series connection of R2 and R3. Then R23 is equal to R2 plus R3. So what is R2? It is 2 and plus 3. So it is 2 plus 3 is equal to it is 5. Is equal to it is 5. Clear about this? Clear about this? Okay. Now this R23 and R1, they are in parallel connection. So 1 upon R is equal to 1 upon R23 plus 1 upon R1 plus 1 upon R1. So is equal to 1 upon R is equal to 1 upon R23 is 5 plus here it is 1 upon 1 means it is 1. Okay, so you will get it is 6 upon 5. You will get it is 6 upon 5. Clear about this? So then what is your answer? R is equal to it is 5 by 6. Then again this assumption is also wrong. Means this and these two cases are not possible. So now remaining two cases are yes, which cases? See, I am here. Remaining two cases are, first of all you take this case, R1 and R2 in parallel connection and R3 is in series connection. Clear about this? R1 and R2 in parallel connection, then R3 in series connection. Then take another case, R1 is here and R2 and R3 in parallel connection. Okay, you will get your answer. You will get your answer. So see, if you have to solve such questions, you have to think possible ways of connection. Possible ways of connection. Clear about this? Clear about this? Yes, these two cases are wrong. Okay, you have to try some more cases. You have to try some more cases to find answer 11 upon 5 ohm and to find answer 11 upon 3 ohm. Okay, what is your answer? Give your answer in comment box. Now question C, find equivalent resistance. You are given two circuits, 1 and 2. Okay, yes, it is one circuit, you have to find equivalent resistance. See, equivalent resistance between A and B. First of all, you have to solve the easiest part. See, from this point A, if charge is flowing from these two resistors is same, means current flowing from these two resistors is same, they are in series connection. So yes, this 1 ohm and this 1 ohm, they are in series connection. And what is their equivalent? It is 2 ohm. Clear about this? Similarly, this 2 ohm and this 2 ohm, they are in series connection. So what is their equivalent? It is 4. Clear about this? Okay. Similarly, 1 and 1, 2 ohm, 2 and 2, 4 ohm. 1 and 1, 2, 2 and 2, 4, 1 and 1, 2, 2 and 2, 4. So I can draw another figure like this. See, here it is. Like this. 1, 2, 3 and here it is 4. Okay, see, here it is 2 ohm 4 ohm, 2 ohm, 4 ohm, 2 ohm, 4 ohm, 2 ohm, and here it is 4 ohm. Now this 2 and 4, they are in parallel connection. So what is the equivalent? Yes, 2 and 4, they are in parallel connection. So their equivalent is 2 into 4 upon 2 plus 4. Means here it is 8 divided by 6. It is 8 divided by 6. So what is equivalent of these two resistors? 2 ohm and 4 ohm, they are in parallel connection. 2 ohm and 4 ohm, they are in parallel connection. So 2 into 4 upon 2 plus 4, 8 by 6. So what is equivalent resistance of these two? 8 by 6, 8 by 6, 8 by 6 and 8 by 6. And such 4 resistors are in series connection. So resultant resistance R is equal to 4 into 8 by 6. 4 into 8 by 6. Clear about this? So is equal to, here it is 2, here it is 2, so it is 16 by 3 ohm. Here it is 16 by 3 ohm. So it is simple. 1 and 1, 2 ohm, 2 and 2, 4 ohm. 2 and 4, that parallel connection. 2 and 4, that parallel connection. It is 2 into 4 upon 2 plus 4. 8 divided by 6. And such 1, 2, 3 and 4 resistors are in series connection. So their equivalent is 4 into 8 by 6. 4 into 8 by 6, and it is 16 by 3. Okay. Now next question. 1, 2, 3, 4 and 5 resistors are given. You have to find equivalent resistance between A and B. Hello. If you flow charge from this point A, then see charge flowing from this resistor. There is only one way. There is only one way. Means these all resistors are in series connection. These all resistors are in series connection. So what is equivalent resistance? Equivalent resistance R equivalent is equal to R plus R plus R plus R and plus R plus R plus R plus R and plus R. So here R equivalent is equal to, it is 5. Clear about this? Okay. So yes, it is your answer. Next one. Say yes. Example over. No extra questions. If you have 3 resistors R1, R2 and R3 shown in figure, then yes, you say between A and B they are in series connection and their equivalent is R1 plus R2 plus R3. But if I say figure is like this, then which type of connection is this? We have to identify. Such method we have discussed in capacitors. Now I am repeating this method. See, let this point is small a, it is small b, it is small c, and it is small d. Clear about this? Okay. As you have to find equivalent resistance between A and B. Okay. Draw A and B points at ends. Now, what is meaning of common point? Common points in between. There are no electrical components, resistor, cell, capacitor or inductor. Here what is common point of this A? It is small a. This A is connected with C. Then yes, it is also its common point. Clear about this? For this B, it is connected with D and then no electrical component to D. So then this D and D. Okay. So yes, what is common point? See, this A and C. A and C, no electrical component, means they are called common point. Okay. Now this first resistor R1 is connected between small a and small b. Here it is small a, here it is small b. Then this is first resistor R1. Okay. This second resistor R2 is connected between B and C. Here it is B, here it is C. Then just here it is second resistor R2. Clear. Third resistance R3 is connected between C and D. Here it is C, here it is D, and yes, third resistor is connected between. So here I can say this R1, R2 and R3, they are in parallel connection. They are in parallel connection. Clear about this? Okay? Okay. One more extra question. 3 resistors are there between A and B connection, as here R, and R. Yes, 3 identical capacitors. Now see, from figure it is clear. These 2 resistors are in parallel connection. So first of all, find their equivalent. These 2 resistors are in parallel connection. two identical resistors in parallel connection, so their equivalent R dash is equal to it is R by 2. Yes, we can write directly. We can write directly. Okay, so now new circuit is it is A, it is B, its resistance is R and it is R by 2. So what is new resistance or final resistance? Final resistance R equivalent is equal to R plus R by 2 is equal to it is 3R by 2. So see, you have to write something directly. Okay, next question. It is one figure, one circuit. Okay, you have to find what is equivalent resistance between A and B. From figure, yes, it is clear. These two resistors are in series connection, so their equivalent is 2R directly. Yes, these two resistors are also in series connection, so their equivalent is 2R. Okay, now if I draw another figure, then this resistor, its equivalent resistance is 2R. This resistance is R, and resistance of this branch, it is 2R between A and B. Now see, for each and every resistance, ends are A and B, means they are in parallel connection. So for parallel connection, what is equivalent resistance? R equivalent is equal to it is 1 upon 2R plus 1 upon R plus 1 upon 1. Clear about this? Okay. So how to find this? 1 upon R equivalent is equal to 1 upon R equivalent is equal to. See, take LCM 2R. So here it is 1 plus here it is 2 plus here it is 1. Okay. So is equal to it is 4 upon 2R. Then R equivalent is equal to it is R by 2. Is equal to it is R by 2. Clear? So yes, it is your answer. Last question. You are given 5 resistors, R1, R2, R3, R4 and R5. And yes, right now they are connected in series connection. So you know how to find their equivalent. But if is equivalent connection is R equivalent is equal to R1 plus R2 plus R3 plus R4 and plus R5. Okay. Now, if such resistors are connected like this, you have 5 resistors, R and R between A and B, and if it is like this, okay, then you have to find what is equivalent resistance between points A and B. See, one similar question we have discussed in chapter number 2 in capacitors. So try to solve this question and write down your answer in comment box.